Alright, so this is from an Algebra 1-2 class, and I just want to go over a brief thing about some of the things we've been seeing. The main idea is I want you to see the difference between linear situations and exponential situations. So first we're going to start with what you know. You've seen this before. Y equals mx plus b. We've graphed that where we saw it was a line. We've also looked at it with a table. So, y equals, let me give you an example. So like y equals 2x plus 5, let's say. What that's saying is, we're going to start at 5, and we're going to grow by 2 every single time. So when I'm looking at a pattern of numbers, I could look at it in a table. So if I made a table, all of my x's and all of my y's, and this is how we're making sense of this. So I can start with any x value I want. Let's say I started at -1. I want to know what happens when x is -1. What's my y value? Well, I look up here and I see y's and x's. So what I want to do is I plug in -1 for x, and then I'll get what y is. So 2 times x, or 2 times -1, is -2, plus 5 is +3. So when x is -1, y is 3. We could take this and look at this as an ordered pair, a coordinate on our graph. We're not doing that right now, we will eventually. So next, we just usually step by just 1. So like from -1, I'm going to go to 0. So when x is 0. Now, you might remember, when x is 0, I'm going to find my y-intercept, or my starting point. We called it the starting point because that's where we would start graphing this on the y-axis. So when x is 0, 2 times 0 is 0, plus 5 is 5. So y equals 5 when x is 0. And we can keep going, right? So what happens here when x is 1? We're going to get 7. And as you'll notice, you might notice, from 3 to 5, we increase by 2. From 5 to 7, we increase by 2. And then the next one, as you would expect, it would be increased by 2 again. So here we're increasing by the same amount every single time. 2, 2, 2. That's our slope, right? That's where that comes from. We're increasing the same amount every single time. There's other situations where that doesn't happen. We don't always increase by the same amount every time. There's a lot of situations where that doesn't happen. And we'll look and see what that looks like. So first we start off with something else, and it doesn't look like what we saw before. It's still y equals, but now instead of mx plus b, we're going to have a times b to the power of x. So that x is our variable, and it's an exponent. So our exponential equations look like this, where the variable is in an exponent. Okay? So an example, here's an example one, y equals, let's say we're gonna, and our a is working, it's very similar to our starting value of b before, where we started our sequence when x is 0. It's actually not a sequence, I shouldn't use that word. So a will be, let's say it's, I don't know, 5. And then this is kind of like our growth rate. Let's say it's 2 to the power of x. Again, I can look at a table of values. So what happens when x, and I'm going to start just to be simple, I'm going to start when x is 0. When x is 0, what is y? So I'm asking the same questions I asked before. I'm just working with a different looking equation, right? So I'm going to plug in x equals 0 up here and figure out what y equals. So 5 times 2 to the power of 0. And I always do exponents first because of the order of operations. Please excuse my dear Aunt Sally. Hamdas. So 2 to the 0 power, you might not know that because we haven't gone over that yet, but 2 to the 0 power, or anything to the 0 power, is actually 1. A lot of people think it's 0. It's actually just 1. We'll learn that later when we look at the laws of exponents. But you can put it into your calculator. When you put it into your calculator, you do 2, and a lot of times there'll be this little caret thing. I call it a caret. It's just like a little top of a house. It's the symbol that's used. And then whatever comes after it is the exponent, so to the 0. but it's written when I write it. That's how you plug it into a calculator, but when you write it, you just do 2 to the 0 power. That equals 1. So 2 to the 0 power is 1 times 5 is 5. So our starting value here is 5, and you'll notice there's the 5 out front. So this is what we're always going to start with in our pattern for our first term for x equals 0. So then x equals 1. Well, 2 to the first power is 2 times 5 is 10. So some of you might say, okay, well, what's going to be next? It's going to be 15. Well, maybe. Let's find out. Here's x equals 2, right? So then 2 to the second power, or 2 squared, is 4 times 5 is 20. So now you're saying, okay, well, it increased here by 5, but it increased here by 10. So it doubled the amount that it increased. Really what's happening is, instead of adding the same amount each time, we're actually multiplying times what we had before. We're taking 5 and we're doubling it. And where do you think the double came from? Well, 2, double, right here. If I were to change that 2 to a 3, I would triple it. If I change it to a 4, I'd quadruple it. So each time I'm multiplying times the same amount. And the reason that is, behind the scenes is, for this reason. If I take 5 and I multiply times 2, and then I multiply times 2 again, and then I multiply times 2 again, and then I multiply times 2 again, that would be 5 times 2 times 2 times 2 times 2, which is the equivalent of 5 times 2 to the power of 4, right? Because 2 to the 4th is 2 times 2 times 2 times 2. I did it 4 times. Well, what if I added another 2 on the end? If I just do this times 2, that's the same as to the 5th power. And I can keep going and going and going. But I don't want to write all that. So I'm going to write, instead of that, I'm just going to go back and say, okay, how many times do I want to multiply? How many times am I doubling this? Well, since it keeps going on forever and ever, I just do it x times, however many times. X is a number, and it keeps going on and on and on and on. We can ask different questions about that. When we get to negative exponents, we're going to talk about what happens with the negative values, but you can still plug those in. So you can still plug it into your calculator as 5, and then you could type in 2, and then you could type in a caret, or this little top of the house thing, and then type in your negative 2. In your calculator, you can type that, and the calculator will know to take 2, raise it to the power of negative 2, and this negative 2, it's just a symbol at that point. It's not a number. It's just a symbol. So it doesn't mean a negative value. It actually is just a symbol there, well, for different reasons. So it doesn't make it negative. It just changes, what is actually happening is it changes the side of the fraction symbol it's on. So it makes it 1 over 2 squared is equal to 2 to the negative 2nd power. And we'll go over that later. But I just wanted to give you a brief overview of how that works. If you're looking at patterns, this is what you need to remember. This is exponential, and that's very different from the linear. The other pattern that we've seen is quadratic, where we had things that look like this. This is quadratic. There's our lines. Those were the linear ones. And then now we have exponential, where it's constantly increasing. We're also going to look at when it constantly decreases, right? Because we didn't always see these parabolas where they opened up. Sometimes they opened down. Just like sometimes the lines were decreasing, depending on the slope. So a lot of different situations that they come up with. And they're useful for a variety of different situations. So hopefully that makes sense for Algebra 1, 2, or for anybody that forgot all this stuff. Thanks.